In this example, we're going to heat up a ammonia stream from 375 to 750 Kelvin. And the question is, how much heat must we add to the stream per minute if we're flowing at a rate of 100 moles per minute? We want to use temperature-dependent heat capacities. We're going to use, in this case, A plus B times temperature plus C times temperature squared, where temperature is in Kelvin. That's important. And the constants are given here. And this heat capacity equation is applicable from 300 to 1500 Kelvin, so it covers the range that we're interested in. So we're going to use the first law, where N dot's molar flow rate of ammonia, change in enthalpy per mole. This is the heat added per time. And delta H, going to be integrating from inlet temperature 375 to 750. This is Kelvin. And our heat capacity A plus B times temperature plus C times temperature squared. So this integration, straightforward, and then we're evaluating this between 375 and 750. Remember, this is Kelvin, so let me write that there. And so we can substitute in the numbers for A, 24.619, and then we have 750 minus 375, and for B, 3.75 times 10 to the minus 2 over 2, and then we have 750 squared minus 375 squared. The last term is minus 1.38 times 10 to the minus 6 over 3. And 750 cubed minus 375 cubed. So then to get Q dot, right, heat's being added, as we said, N dot times delta H. Delta H is all of this. N dot is 100 moles per minute. Delta H here, I'm not going to rewrite those numbers. And then I'm going to do a conversion from joules to kilojoules. The heat capacity is in joules per mole per Kelvin. So CP, it's important, joules per mole Kelvin. And this number I just put into a spreadsheet, 1,697 kilojoules per hour, which realistically 1,700 kilojoules per hour is Q dot, and that's what we're trying to determine. So let's look at the spreadsheet. So here's the spreadsheet where I put in the values and then calculate each of these terms, and got the integral converted to kilojoules, in this case kilojoules per minute. And so the spreadsheet will be stored on the LearnChemE website.